Hello, students. This week in Module 2, you're going to take the first quiz, so make sure you allow time for that this week. Honestly, my quizzes are not that difficult. They tie directly to the reading assignments in your book. You should do well in the quizzes. Okay, the big thing in this module is about seasons and moon phases. And I have a lab you're going to work on, and it's several pages long. If you print out a lab and you write on it, that's great, that's fine. When you upload multiple pages for me, you need to upload them as a single file, like a .pdf file or a .doc. I can't open .pages files, and I can't open Google Doc files in the grader within Canvas. So a PDF is preferred, or a Word doc, or a docx. And then if you want to scan in your pages, there's a free scanner app called Genius Scan. And I have that listed in the assignment, where you'll turn the assignment in this week. Genius Scan. You can scan multiple pages and then upload them as one file. Okay, seasons this week. Let's look at the lab a little bit. You're going to look at the number one misconception in astronomy is that something that causes seasons, something has to do with the distance. Most people, well, not most, but a good number of people think Earth must be closer to the sun in summer and farther away in winter. Well, look at this from your first page of your lab. We're actually closer in December and much farther in June. Our overall distance from the sun averages 150 million kilometers, or 93 million miles. A few million kilometers is a lot to us, but it doesn't make any difference in terms of seasons. Tilt of the Earth and Earth's orbit causes the seasonal changes on Earth. Now, on the second page, if you look at this diagram, you can clearly see the top line is shorter than the bottom line. But this might be the worst scale drawing in history. The sun is 150 million kilometers away, or 93 million miles. The fact that Earth is tilted this way and this hemisphere might be 2,000 kilometers closer to the sun doesn't make any difference when we're talking 150 million kilometers. So don't fall for the idea that distance is a factor. Again, I can't stress this enough. Distance does not have anything to do with seasons. All right, scroll down here. I want to show you this. It's on page 92 of your lab. One thing I encourage you to do, there's a free program called Snip and Sketch in Windows. And I like this because I can go in and grab a diagram like this and mark it up, maybe to help me make more sense of it. But I wanted to show you this. I'm going to draw the equator on here on the left side first. I'm going to try to make it as straight as I can. And then I'm going to draw it over here, straight as I can. Again, I'm using Snip and Sketch. It's a free program in Windows. And then notice, I'll change the color here, make it yellow. I'm going to extend this middle arrow, and we'll call this the most direct sunlight. Notice that the most direct sunlight here on this side hits below the equator. So that's going to be winter for the northern hemisphere. Then on the right side, let's extend the arrow over. Oh, it's got a little wavy. All right. And notice the most direct sun rays hit above the equator on the right diagram. So this would be summer for the northern hemisphere. The tilt didn't change. Tilt didn't change. It's just from here to here, Earth's orbited 6 months. So a program like this might help you, because you're going to have to determine which of these numbers is summer or which of these numbers is winter. And by the way, when you're at the equator, your climate changes very little. So not too worried about number 2 and number 5 here. But pay attention to 1, 3, 4, and 6. All right. The second part of this lab is the cause of moon phases. And this is probably the number 2 misconception. Misconception being a wrong idea that's commonly accepted, that that's how it works, but it doesn't. Seasons is number 1 and moon phases is number 2. So what's the wrong thing people think about moon phases? They think it has something to do with Earth's shadow. You'll read in chapter 1, Earth's shadow, when it hits the moon, that causes a lunar eclipse. And when the moon shadow hits Earth, that causes a solar eclipse. So shadows are only involved in eclipses. So shadows have nothing to do with the phases of the moon. It's just the moon orbits around Earth, and sometimes we see it reflect more light. Sometimes we see it reflect less light. Sometimes it reflects the light completely away from Earth and we have new moon. So just keep in mind when you look at this diagram, notice that the moon always is about half illuminated. That's right. Can we see that from Earth all the time? No. Over here, where A and B are at, A would be like waxing gibbous moon. B would be like waning gibbous moon. And if you could see this perspective off in space somewhere, you would see that no matter where the moon orbits, it's always half illuminated by the sun. But that's not how we see it on Earth. So you have to picture from Earth, what would we see at the moon at A, B, C, D, E? Your textbook has a nice page in it about moon phases. That'll help. And I've attached a video link about moon phases that'll help. All right. Those are the 2 main things about seasons and moon phases. Seasons have nothing to do with distance from the sun. It's tilt of the Earth, which stays constant, and the orbit of the Earth around the sun. And then moon phases have nothing to do with Earth's shadow. All right, shadows cause eclipses. All right, well, I hope you guys have a good week. Make sure you take quiz number 1 and email me if you have any questions. And I hope you're off to a good start this semester.